All right, you guys, make you feel it. Class.
Yes.
Remember a moment ago when I said, hey, I challenge you. See if you could actually just homework done first. And yeah, keep your phone off and away. Just turn it off. Do you remember that?
I thought you said we could do what we were.
I know. Here, on this. We're gonna do this one first. Okay, we're gonna do this, and then, all right. So we're gonna go through, find the values of a and b in the pair of similar triangles. Now, if you remember when we were doing these, we started off with pairs that I know, corresponding sides that I know. So I'm looking for one in both of them that they are the corresponding sides. Which two numbers go together? 27 and 9, right? So that's my starting off point. So I have 27 in this one, 9 in this one. So I'm going to put 27 over 9. And we're going to do cross products on this. So do we want to solve for A or solve for B? B? Okay. We're going to solve both, but whichever. Someone said B, so we're going to do that one. Now, what corresponds with B?
30 over
30 and B, right? So now if you notice, 27 is on top, so that's a big. This is a little. And so it's going to be 30 over B. And from here, what's that stuff called that we do? Cross product. Cross product. It means multiply, but you know, it's the same thing, but the term is cross product. So 27 times B. 9 times 30. 270. Hopefully. Am I right there?
Yeah.
Okay. And what would I do to get B by itself?
Divide by 27 on both sides.
Yeah.
So you get B equals 10.
There we go. I got one of them.
Do it for the other side now.
Yeah. So what am I starting with on this side?
You could start with either or now. 27 over 9 and 30.
I highly recommend starting with the one that's given to you in the first place.
27 over 9.
Because what if you made a mistake here? If you made a mistake on this one here, then you're definitely getting it wrong. So it's possible to get one wrong and the other one right. Yes?
Yes.
Okay, so that's why I always go back to my original one. So I'm going to start off with the 27 over 9. Now, how am I going to write this next one out?
27 over
27 over
8.
A. And then cross products again. I want orange this time. So let's see. So 27 times A. 27A. 9 times 27.
729.
729?
Yeah, sure. 27 times 27. 720. I was in the calculation.
It's 27 times 9.
Oh, times 9. Oh, I was doing 27 times 27.
It's because there was a 2 at the end.
243. Yeah, I was like, yo, that number's big.
243. There we go. All right, and how do I get my A by itself? Divide by 27. There we go. So letter A, S. 9.
Yes.
Is 9.
Yeah, because you divided.
Yeah, there we go. All right, you guys feel pretty good about this now? I hope so. I like little circles around my answers. It makes it easier for me to grade. And if it's easy for me to grade, guess what?
I boxed.
How dare you box it? I don't care. Okay. You know, I don't mind either way, as long as I can tell where it's at.
I'm like, you talking about circles? I'm like,
Listen, I don't have a problem with it as long as it's easy to read and I can find your work.
8 squares. 8 squares from
Number dos. Number dos. An airplane propeller rotating 1,000 times per minute. Through how many degrees does a point on the edge of the pulley move in 1 second? Okay. So, let's see. What is one rotation?
360.
360, right? So, on this, look, I'm going to do, and then, and so it's going, let's see, it's going this way. So it's going, and then this one going, like that, right? So, around the outside, like that. And so we're trying to count this, right? And that's per minute, 1,000 times per minute. So let's first convert it to degrees. So it's going to be 1,000 times 360, right? Because every time it goes around, it's 360 degrees. Which is going to give me 360,000 degrees, and that's per what unit? It's in a minute, isn't it? Now we're going to have to do a unit conversion on this one, because that's every minute. I only want to figure out what it is per 1 second. So let's go. So it's 360,000 degrees over 1 minute. And what do I want to get rid of? I want to get rid of the minutes, right? So if minutes are right there, where is minutes going to have to end up at?
The top.
Top. Why top?
Because
So it can cancel, right? So if minutes are right here on bottom, I need minutes over here on top, if that's what I'm trying to get rid of. So minutes here. And what am I turning those minutes into? Seconds. So down here on the bottom, it's going to be seconds now, right? Now, in my numbers, so what number should I put in front of minute? 1 minute is, there we go. And then we can go ahead and do our math on this. And what's going to happen to my minutes? Very good, minutes cancel. And then it's going to be degrees divided by seconds. And do the math. I should get, it's at 60,000 degrees per 1 second. Hopefully? I don't know. I kind of suck at this. Did I do too many zeros?
Yes.
1 too many, right? Okay. That's what I figured. It's 6,000 degrees in 1 second, right? Yes? Okay. All right, you guys feel pretty good about this? It's pretty easy, right? What was the problem that we had on the homework that was similar to this? Conversion, and what did it ask for? Didn't it say something about 2 seconds? Might have been our notes that we had it. There was one of them that actually said it was 2 seconds. What was your answer in 2 seconds? So if I was asking for, okay, how many degrees in 2 seconds, what would I do with that?
you would divide that.
What is 2 times 2?
Multiply, yes, so twice as much, right? So what if it was in 3 seconds? times 3, right? In 3 seconds. That's what I'd be looking for. All right, number 3. So I don't know if you guys remember these problems right here. I said these are something special. You have to do something special with. In the homework, we did these also in the notes. These type of problems with a linear, we don't have x's and y's. What are the 3 things we need to get our 6 trigonomic functions? X, y, and r, right? So we need x, y, and r. But I have this right here. What do I do to try and make this work? You guys remember this? Do you remember this? Okay. Kind of make it a table because you don't have x and y's. You have a line, right? And what x's am I going to use?
6x.
The ones that are greater than or equal to 0.
Those are the x's I'm going to use, right? Do I want negatives?
No.
No, I don't want to plug in negatives. I only want to plug in positives. I only want to plug in positives. So in this case right here, this is why I stopped the lesson. I said, hey, why would I choose these type of numbers here? So I could choose any x values. I could choose any x values. What x value do I want to use here? Yes, greater than 0, right? But what do you think my first one should be? What? Okay, try 1. What'd you say? 6. That would be a good one. Almost up. Let's try 1. Let's see what happens when I plug in a 1. So I'm plugging in 1 for my x. So it's going to be 6 times 1 minus 5y equals 0. 6 times 1 is?
6.
Right? 6 minus 5y equals 0. What am I doing with that 6 right there?
You're going to subtract it, get on the other side.
Yeah, minus 6 to both sides. So negative 5y equals negative 6. And to get y by itself?
Divide -5 with -6.
So y is positive
6.
6/5. Do I like that?
No.
No.
Why?
But
It's a fraction.
It's a fraction. It's not a good one, is it? Why 5?
Because so if you were to do 5, it would be 30, because you have to do 6 times 5, and when you subtract it to the other side, and you divide it by 5, it would be y equals 30 divided by
So you're going by what you're dividing by, right?
5.
And so you're going to try that. So let's see. I'm going to erase what I have here.
Oh, go ahead. Get on it.
All right, let's see it. So 6 times 5 minus 5y equals 0. 6 times 5 is 30 minus 5y equals 0. Subtract.
30.
Yep. So negative 5y is negative 30. That's 30. Divide by negative 5. Y is
6.
positive 6. Okay. Now we don't have fractions, do we?
No.
We don't have fractions, we don't have decimals, we have good numbers here. Because once I find my x and my y, what am I still missing? R. And do I want to plug 6/5 into the Pythagorean Theorem?
No.
Hell no, I don't even want to do it. I get paid for this. All right, so we're going to say our x is 5, our y is 6, and my r is, don't know yet.
So I do Pythagorean Theorem.
Yep. So r is equal to the square root of
25 plus 36.
like that, right? This is from the formula that was straight in our notes. R equals square root of 25 plus 36. 41. Yes?
Nope.
61. Huh?
661. 2 plus 30.
50, 60. Okay, see? Seeing if anyone's paying attention.
He was just testing his guys.
Because a lot of times people just say, yeah, that's it. You know, I try to give you guys credit for having a brain too. Now, do we know x, y, and r?
Yes.
There we go, x, y, and r. So let's go through and find our 6 trigonomic functions. So starting off with,
Tangent.
what do you want to find first?
Tangent.
Tangent?
Yeah, sure.
All right, what does tangent represent?
X.
Y over.
Y over x. You're getting there. You're getting there. Okay, tangent is y over x, and my y value is?
6 over 5.
6 over.
Very good. All right, how about cotangent then?
It's gonna be 5 over 6.
Because cotangent is the opposite, right?
Uh-huh.
It's the reciprocal, so it's going to be 5 over 6.
And then sine is the y over r, right?
Okay, so I'm going to do sine is y over r. My y value was 6.
Over, yeah, square root of 6 over, but you gotta rationalize it. 'Cause,
Got to rationalize.
it's gonna be 5 rad, oh wait, no, it's gonna be.
So rationalizing, I'm going to multiply top and bottom by,
Square root of 61.
very good, square root of 61 like this.
So it's 6 rad 61 over 61. Yeah, right.
Yes? You guys agreeing or going too fast? All right, so we get 6 square root of 61 over 61. Next one we're going to do is going to be, Cosine. so cosine theta. What was x over
It's gonna be 61 over 60. Yeah,
cosine is x over r, right?
yeah. Is it?
5 over,
Over square root of
very good. Square root of 61. Rationalize again. Oh, thank you. Do the math and we come up with
5 is square root of 61.
5 square root of 61 over.
61.
Very good. Hopefully this is getting easier here. And we're missing some, so that's going to be, let's go cosecant. So CSC. What does cosecant represent? R over y. Very good. R, and my R value is?
Rad 61.
Square root of 6.
And my y is?
6.
Do I have to do anything special?
No.
No. It's good, right? Last one is secant. What is my secant?
R over.
R over x, so my R value is?
Square root of
My x is?
5.
Very good.
Okay.
Alrighty. And last one. You're going to find the other ones. Find the remaining trigonomic functions. So it gives you cosine. So to do these, I need three things. I need x, y, and r. X, y, r. It gives me cosine. What does cosine represent? I heard it.
X over R.
X over r. Cosine is? Very good. It's x over r. So what is my x value here? Square root of 5. X is square root of 5. Y is? Don't know yet. Don't know yet, but r is? There we go. And given that tangent is going to be less than 0, what numbers are less than 0? Negative, right? Negative numbers. And we know tangent is? Very good. So y over x. And right now, my x value is that positive or negative?
That's positive.
It's positive here. So for this fraction to be negative, what's got to happen with my y?
The top one is going to be negative, or y is going to be negative.
Y has to be negative, right? Because for the whole thing to be negative, I need only one of them to be negative. So that means that my y has to be negative right there. And that's where we get this, do all that information there. Let's do my Pythagorean theorem. Square root of 5 squared plus y squared equals 8 squared. Square root of 5 squared gives me 5 plus y squared equals 8 squared. Bless you. What am I doing to that 5?
Subtracting.
Yes. Get rid of it. Y squared is
59.
59? Maybe. Yeah? Maybe?
Yes.
Okay. And how do I undo a square?
Oh, square root.
Square root both sides. So y equals, now this is where it came in, plus or minus square root of 59.
But it has to be the negative.
Has to be a negative. Why does it have to be a negative?
Because tangent was negative, or cosine was negative. Yeah, tangent.
Very good. All that information that we were talking about at the beginning, when we stated that the y value has to be negative. There we go. So we have to find the other 5. We already have cosine. Find the 5 remaining. So we have cosine. Let's do sine. What does sine represent? Y over r. Sine is y over r. So negative radical 59 over 8. We already have cosine. Next one's tangent. What is tangent? Y over x. So my y value is negative rad 59 over rad 5.
The rational.
Got to rationalize. But this time I have 2 radicals now.
You just multiply what's inside, no?
Yep. Multiply the insides together. Is there anything on the outside? So I just leave the negative, right? I leave the negative alone.
So it's going to be 59 times 5.
Times 5.
295.
What is it?
295.
295? Over 5. There we go. There's tangent. And then let's do, next one after that is going to be cotangent. What is cotangent supposed to be? X over y. Very good. So radical 5 over negative radical 59. Rationalize again.
Would it not be? Oh, wait, yeah. Well, it's going to be the same thing, I guess. But
No, it's not.
but like the denominator is going to be different. Because it's still negative 59.
Yeah.
5 or
So there's the negative out front.
Yeah, denominator's gonna be different though.
So it's going to be negative square root of 295. Is that what you're trying to say?
Yeah, so that's gonna stay the same.
Over
59 this time.
just 59 this time. Sine, tangent, cotangent. Let's go down the reciprocals now.
Secant,
Cosecant. Let's go cosecant. Bless you, I think.
I know what I'm saying.
So what does cosecant represent? R over y. So my R value was, my y value was,
Negative 59. Or negative square root 59.
there we go. All right, let's rationalize.
It's gonna be rad 8, or no, 8 rad 59. Negative, what, the negative in front of all?
Negative out front.
Negative 8 rad 59 over 59.
There we go. Last one. Last one is
Oh, yeah, cosecant.
secant, right?
Oh, yeah, secant.
What is secant going to be? 8 over there you go, square root of 5. There we go. You guys feel pretty good about it, hopefully? So, make sure you guys like, share, and subscribe. Hit that notification button and finish your other review. We're taking the test on Thursday.